Good evening, my 11th standard warriors. Have you ever wondered what's the physics behind a pendulum? What's the acceleration look like? What kinds of forces are acting on a pendulum? And how about Hot Wheels? Or the track which loops around, and you might have seen some stunts where a bicycle or a car does a vertical circular motion. So what's the speed required at the bottommost point to complete the loop? So all of this. Hello everyone, this is Shreyas here, your physics master teacher, and I'm going live. I hope you can see me. I hope you can hear me loud and clear. Good evening Arita, good evening Suchi Mama, hello Dakshin, Ishpreet, welcome. So in case you are new to the channel, first of all, welcome to JEE Enthuse. This is a special English medium channel for all the aspirants who want to crack exams like JEE, KVPY and other such things. And you are right now watching the Nurture series, which is a long-term series. There are lots of classes for 11th standard and all the chapters will be completed. Right now we are in the third lecture of circular motion, and within no time you will be seeing that we'll be reaching momentum, center of mass, rotation and SHM, and slowly gravitation, and towards the end of 11th standard. So if you want to make sure that you get all the lectures, if you want to make sure you get the PDFs, you get the important information, also the KVPY preparation, you should do one small favor. Go smash that subscribe button in case you haven't done it. And if you have done that, please smash the like button down there. That shows us your love, your support towards the channel and towards me. So welcome aboard. And now there is also a special surprise which is coming up very shortly, because it's a month full of festivals, lots of things coming up, and you will see lots of surprises. So stay tuned guys. So that's one reason why you should hit the subscribe button. Also, we are awaiting our JEE advanced results, but meanwhile you should also know, in case you are new to Vedantu or this channel, that our students, be it board examinations or CET or JEE mains or KVPY, they have aced it every place. Every single exam that you can think of, you'll always see Vedantu toppers, you'll always see Vedantu students doing really well. And it's not just about the topmost rank. A lot of institutes only talk about the topmost ranks, but we tell you that more than the toppers is the number of students who get a decent score. And there were almost 900 plus students within top all India rank 10,000. That's almost like 1:10 student out of 10,000 all India rank is from Vedantu, and that's a big deal. And if you're looking forward to join Vedantu, there is a batch which is starting on Monday. You can definitely check out the link in the description box, and you will get all the live classes with recordings, test series, assignments, notes, doubt solving, personal mentorship, all the different packages mentioned very clearly in the description box. There is a link, and you can use my coupon code SHHPRO. You will get the course for almost like 3,060 rupees per month. That's very cheap, and the kind of things that you get for this money, it's definitely value for money. So go ahead, check it out. Now let's do a quick recap. Now last lecture we have spoken about centripetal force, centrifugal force. Now centripetal force is that force which changes the direction and it provides the acceleration towards the center. And we have seen different terminologies like angular velocity and angular acceleration. If you remember, angular velocity is very similar to velocity in circular motion. How much angle you cover per unit time is angular velocity omega. So it is expressed in radians per second or rounds per second or rounds per minute. How many angles or how many rounds you cover per unit time, that's angular velocity. Now in uniform circular motion, the angle that you cover per unit time is same, but in non-uniform circular motion, you can easily guess this, the angle which you cover per unit time won't be same. You will cover different angles per unit time. So that leads us to angular acceleration alpha. Alpha, which is angular acceleration, is the rate of change of angular velocity. How quickly angular velocity changes, that's angular acceleration alpha. The unit is radian per second square. So it's very similar to acceleration in linear motion. Acceleration changes velocity, angular acceleration changes angular velocity. As simple as that. Okay, so we have seen all of this, and one last thing which we ended last time or even before that was acceleration is r alpha. Now we will be using this equation very frequently, and let's probably talk about this equation and probably talk about non-uniform motion a little bit more in detail, because today's lecture is all about non-uniform circular motion. We have spent quite a lot of time on uniform circular motion. Now we need to know how things work when the speed is not constant and it is accelerating angular wise. So get set, go guys, and if you are new to the channel, do not forget to hit the subscribe and also smash the like button down there. Now just imagine this, okay? If there is a particle and let's say its speed increases, okay, so we say that it is accelerating along that straight line. Now imagine there is a particle and let's say it is going in a curved path with constant speed. Even though the speed is constant, it is still said to be accelerating because the direction is changing, and we can see the velocity vector is changing the direction, and that acceleration is always directed towards the center of that curved path, the circular path. That acceleration is called as centripetal acceleration. So centripetal acceleration is only responsible for changing the direction. It only changes the direction, and we have seen that the centripetal acceleration is either v square by r, or you can use omega square into r. One of these two things. Now you can combine both these things and you can guess what will be our next diagram. Imagine there is a particle going in a curved path, but it's not going with constant speed. So right now the speed is less, after some time the speed is even more, and let's say after some more time the speed is even more. So in this case it's turning with let's say varying velocity or speed, I can say varying speed. The moment this happens, apart from the centripetal acceleration which is trying to change the direction, so yes, there is centripetal acceleration obviously which is trying to change the direction of the motion, there is one more additional acceleration like you would expect for a particle whose speed is increasing. So that acceleration is along the tangent. Yep, so there is an acceleration along the tangent. Every time it tries to increase its speed, there is a tangential acceleration. So this is nothing but your tangential acceleration, and this is only responsible for changing the speed of the particle. So if you remember this much, it is very, very helpful for solving or getting to some conceptual level understanding. Tangential, which is along the tangent, changes the speed. Centripetal, which is perpendicular to the tangent, changes the direction. Is that clear, my warriors? Yeah. KSA friends have already taught work power energy. That was the last chapter. You can check it out in our playlist. It's all there. Yep. Okay. So Ashin, there is a micro course of important derivation in the Pro subscription. If you join that if you join V Pro, you will see my course on all the derivations of 11th standard. So all those derivations which I have taught in the micro course are all important. But if you still need some help, you can leave a comment below after the video and I'll definitely help you out. Okay. Chalo. Now, once you understand this particular concept, let's show this over here. See this? There's a particle. It has some centripetal acceleration and it also has some tangential acceleration. The total of both of them, the total vector sum of both of them will be somewhere here. That is your net acceleration, because it will have both kinds of acceleration, centripetal or towards the radial acceleration you can say, and this is along the tangent. So the vector sum of both of them will give you the total or the net acceleration. So this is what it is. This is nothing but AR, okay, or sometimes people also call it as a centripetal, one and the same thing, and this is AT, which is the tangential acceleration. So this is tangential along the tangent. And what is this? This one over here, which you can see, this A over here, this is the net acceleration. Obviously, the net acceleration should be the centripetal acceleration vector plus the tangential acceleration. This is vector wise, but magnitude wise you can guess, because this forms a right angle triangle. This is AC, this is AT. Okay, by Pythagoras, you know standard formula. This will be magnitude wise AC squares magnitude plus AT squares magnitude. I hope that makes sense. I hope this is clear. Very good. Hello Amina, welcome aboard. Yep. Now the next thing that you should also realize is that what is the formula for AC and AT? Centripetal acceleration, I just told you it is omega square r or v square by r. But what is the formula for tangential acceleration? The formula for tangential acceleration is, remember, it is only responsible for changing the speed, right? So it is just dv by dt, where v stands for speed. So this is nothing but rate of change of speed. There is a difference. There is no vector over here. It's just magnitude. There is no bar. So when there is no bar, the magnitude represents speed. So dv represents change in the speed. dv by dt is how quickly the speed is changing. That's the tangential acceleration. So this is responsible for direction. This is responsible for speed, like I just told you. One last thing. You might be wondering, sir, what will I get if I put dv bar by dt? Well, dv bar by dt is the total change in the acceleration. So understand the difference between each term. When I say dv bar by dt, this dv bar represents change in velocity. How much did the velocity change by? Now velocity is a combination of direction as well as magnitude. Keep that in mind. So this total acceleration is a combination of centripetal and tangential. So takes into account how much is the directional change, which is centripetal, and how much is the tangential or the speed change. So that's combined together. So it's a vector. It combines both the directional change as well as the speed change together. So that will give you total acceleration A. So whenever you see vector, this is just definition. Everybody knows this. Rate of change of velocity, that's acceleration. But rate of change of speed is not acceleration. It is the acceleration along that line, along that path, along that tangent. So that's why rate of change of speed is tangential acceleration. Get this in your head. Everybody clear? Yes, speed is the magnitude of the velocity. That's very true. So bring this concept in your notes. Make sure you write it down in your notes. Rate of change of velocity is acceleration, total. And velocity meaning both, the direction as well as the magnitude. But the rate of change of speed, that's only the tangential acceleration. And this directional part is centripetal. Now, if there is acceleration, obviously there should be force. This is always true. Force is the mass of the body into the acceleration. So think about it. If there is centripetal acceleration, there must be centripetal force. And if there is tangential acceleration, there must be tangential force. And if there is total acceleration, there must be total force. That's it. So again, the same logic over here. The total force is centripetal force plus the tangential force. What is the centripetal force? It's mass into centripetal acceleration. What is the tangential force? It's mass into tangential acceleration. As simple as that. Nothing great about it. Okay. Now, who is this force? It's not a new force. Is this a new force? No. It's a name given to that force which is along the tangent. For example, let's say there is a mass, okay, over here, and let's say there is tension acting like this, and the particle is going in a curved path in this manner. Just example. Then this tension will have two components. One component here, one component here. Let's say, for example, this is theta. Now, this T cos theta, this will be the centripetal force because it is towards the center. And the T sin theta will be the tangential force because it is along the tangent of the path. So, if we had to write anything by Newton's law, you will say T sin theta is mass into tangential acceleration. And T cos theta, you will say force is mass into acceleration, but this is centripetal acceleration. So, try and understand that this mass, my warriors, okay, experiences a force at some random direction, a component of the force is now called centripetal, a component of this force is now the tangential. So, it's a name given to a force or the component of the force. It's not a new force in itself. As in, you do not show centripetal force separately in the diagram. No, you'll never show tangential force separately in the diagram. You label this, you call this only as the centripetal and you call this force itself as the tangential force. I hope this is clear, my warriors. Is that cool? Everyone clear about this? Let me know by putting up a yo or a fire or a smiley in the chat box. And if you are joining in late, you can still go a little bit back. You can catch up at 2x speed to the current state wherever we are. Okay, and don't worry guys, you're going to get all the notes as well over here. Okay, so don't worry, you can read through all of this later on. Now, one question in many students' mind would be, just like you had kinematic equations, V is U plus AT, S is UT plus half AT square, and V square is U square plus 2AS. Do we have something like that in circular motion? Well, you bet it. It is there. Definitely it is there. And that is kinematics of circular motion. So just imagine this. If you have, okay, a body or a particle or any object which is right now moving with some initial angular velocity, this is at t is equal to 0, and as it moves after some time, let's say it gets some angular velocity omega f, this is at some time t, and definitely it would have probably covered some angle, I don't know, maybe like this, let's say it has covered some angle or angular displacement delta theta, then it has to have some angular acceleration because the velocity has changed. So let's say this is the angular acceleration, and assuming if it is constant, and it is given that it is constant, then just like you had V is U plus AT, you can write, instead of final velocity, you have final angular velocity, instead of initial velocity, you have initial angular velocity plus acceleration, instead of that you have alpha, and time is as it is. As simple as that. This is the first kinematic equation of circular motion, and you got it. And the second one, instead of displacement, you have the angular displacement, how much angle you have covered. You can see that this one over here is the angular displacement, how much angle was covered in that time interval, will be U will be omega initial into time, so that's ut plus half, instead of acceleration alpha, and instead of t square it's just t square again. And the third kinematic equation, the final velocity square would be there, instead of v square is initial velocity square plus 2 into acceleration will be replaced by alpha and displacement by angular displacement. So these are your three kinematic equations, and these can be used only when angular acceleration is constant, and you will see that most of the cases it will be, and if it is not, you know what to do, use derivatives and integration. That's it. Glad to know that, Ashwin, and keep following. I hope I'll see you very frequently on our channel, Ashwin. Yeah, and get your friends along too. Hello Army Girl GBTS, welcome aboard. Hi Motivator. Oh my god, Chaitra, it's thundering here too, and there were loud explosions. I felt that there was some bomb which exploded outside my house, and it was like continuous, like some 4 to 5 big explosions, and I was like peeping outside my window what the hell it is, but it was just thunder. I mean, crazy. It's raining heavily in Bangalore too. Okay, so these are your kinematic equations. Get ready for solving some amazing questions up on your screen now. Here we go. Hello Paulini, welcome aboard. Yes, let's start solving this question, and here we have a disk which is starting, and it starts to rotate with a constant angular acceleration of pi radians per second square about a fixed axis perpendicular to the plane and through its center. So it's a normal thing, it's a disk, and it starts spinning with some acceleration. The angular velocity after 4 seconds is how much? And also find angular displacement. So the first answer is one of the options. The second answer, you can probably put it up as a number or whatever you feel like in the chat box out there. Okay, so there are two questions. The first question's answer is one of these options. Let's try to think how we can solve this. So you have a disk, this is the axis, and yeah, there is some angular acceleration. So let's try to see. I know alpha, okay, alpha is nothing but pi, okay, it starts from rest, so omega initial is 0, okay, and the question is after 4 seconds, so time is 4 seconds, and we have to find what is the angular velocity after 4 seconds, so we have to find omega f, and angular displacement, that means delta theta. So let's see which all equations will we use. I think we'll use the first kinematic equation. Omega final is omega initial plus alpha into t. So omega initial is 0, alpha is pi, time is nothing but 4. So it is 4 pi radians per second. But wait a minute, the answers are in hertz. We know omega is 2 pi f. That's the standard formula. F is frequency in just hertz. So 2 pi goes, and f is nothing but 2, per second, or basically that is nothing but hertz. So option C is correct. Done, done. That's the first answer that we got. Clear? Very good, Chitra. Excellent, Suchi. Very good, Dakshin. Excellent, my warriors. Now the second part, angular displacement, delta theta. I think I'll use the second kinematic equation. So delta theta is initial velocity into time plus half into angular acceleration into time square. Initial velocity 0. This term is gone, vanished. Half into alpha. Alpha is, where is alpha? It's pi. Into time. What's the time? The time is 4. So 4 square. So 4 square is 16. 16 by 2. How much it is? 8. 8 pi. But this is radians. And you can write it as 8 pi radians, or see, 2 pi radians is 1 revolution. So 8 pi radians is how many revolutions? 8 pi by 2 pi, which is 4. 4 revolutions. So in 4 seconds, it has now revolved 4 times, or 8 pi radians, and the frequency, the angular speed is 2 hertz. That's it. That's the correct answer. Excellent, my warriors. So now you're getting the hang of using kinematic equations. Let's move on to another question coming up on your screen, and here it is. A wheel, okay, and what it says is that it has some initial angular velocity omega naught. It reaches final velocity 5 omega naught while it turns through an angle of 6 radians. Find the ratio of centripetal to tangential acceleration finally, okay, and I think there was a question over here, and it said what is alpha. Okay, I think that question part is missing by mistake. So first question was find alpha, and the second question is find the ratio of centripetal to tangential acceleration finally. So centripetal by tangential, how much is the ratio? These are the questions. Okay, let's see what we can do. Initial angular velocity, do I know? Yep, it is omega naught. Final angular velocity, do I know that? Yep, it is 5 omega naught. And delta theta, I think I know it as 6 radian. Okay, think which equation we can use. I think we should start with the third equation, because final is known, initial is known, displacement is known, time is not known. So if time is not there, most likely I'll go to the third equation. Exactly, Dashwin. Hi Pankuri, welcome aboard. Come on, bacha log. Welcome, my warriors. And let's use that. Omega final square is omega initial square plus 2 alpha delta theta. Excellent. I will get alpha from this most likely. So this will be 5 omega square, which is nothing but 25 omega naught square, is omega naught square plus 2 into alpha into delta theta is nothing but 6. So 25 minus 1, that's 24 omega naught square. 2 into 6, that's 12 alpha. So therefore alpha will be nothing but 2 omega naught square. So that gives us our first answer. Alpha is 2 omega naught square. I know it was not mentioned here, but that's a misprint. Don't worry about it. Now the next part, centripetal and tangential's ratio. I think I can find tangential by alpha. Last to last class, the first class, I had told you, whenever there is angular acceleration, the tangential acceleration is alpha into r. I had mentioned this. I had started from v is omega r. Just like velocity, you have acceleration instead of omega alpha, and r is as it is. So using that, let's see what do we get. So the tangential acceleration is alpha into r. So alpha is 2 omega naught square into r. So that's tangential acceleration. That's what we got from here. but I also need centripetal. Well, let's see what we can do for centripetal. Centripetal, either I can use v square by r or omega square r. I don't think I have velocity, but I have angular velocity. And what's the final angular velocity? Because they're asking it finally. So the final angular velocity is 5 omega naught square. So using omega square r formula, so I'll get 5 omega naught whole square into r. Now to find this ratio, let's see what we can do. AC divided by AT, that's 5 omega naught square into r divided by this value, which is 2 omega naught square into r. Omega naught square gets cancelled. 5 square is 25. 25 by 2 is the answer. And how many of you have got it before me? Very good, Dakshin, you're smart and you're very quick. Alright, so Nikhil, I don't know, bacha, every day it is different. Very good, Harita, excellent. So this question involved both the concepts, centripetal as well as tangential. One, trick which I tell all my students is this. Length of an arc is r theta, correct? Length is r theta of an arc. Instead of length, if you divide it by time, you get velocity. R is as it is. Theta by time is angular velocity. Now divide it by time again. So velocity by time, tangential acceleration, is r into alpha. So you can remember these three equations in succession. They are very, very similar and identical to each other. The linear term is radius into the angular term every time. So that's what we have used here. So for tangential there is a different formula. For centripetal there is a different formula. And this question also combined kinematics. So that's the best part about it. So a lot of concepts in this question. Very good, Suchi Mama. Excellent. Okay, let's move on to the next question coming up on your screen. Hello, Logeshwari, welcome aboard. Excellente, Nikhil, excellente. Now there is a mass of 0.2 kg. And what is happening is that it is rotated in a vertical circle using a string of length 10 centimeters. When the string makes an angle of 30 degrees with the vertical, the speed of the mass is 3 meters per second. The tangential acceleration of the mass at that instant is, my God, looks scary, but maybe it is not. Let's try and do this. Okay, so first of all, this mass is making some angle of 30 degrees with the vertical. So let's just draw that first. So this angle is 30 degrees. Very good. The mass is 0.2 kg and the length is 10 centimeter. That means it is 0.1 meter. That's right. Okay. Next up, well, what else we can do? Think about it. Acha. This mass is 3 meters per second. Okay, velocity is known, but the question is tangential acceleration. Acha. Tangent is along this line. So let's try and draw the forces on it. What are the different forces? One is obviously the tension and the second one is obviously its own weight. Now the tension is already perpendicular to the tangent. Just think about it. This is the tangential direction. The tension is already perpendicular to the tangent. So I think there is only a component of mg along the tangent. So if you split mg, okay, if you split this mg into two components, I think one component will be here and the other component will be here. Okay, this angle undoubtedly will be 30 degrees. This will be mg cos 30, but this will be mg sin 30. And this force is your tangential force. And what does tangential force do? I just told you. The tangential force gives tangential acceleration. So what is the tangential force? mg sin 30 is equal to mass into tangential acceleration. So goes, so at will be g sin 30, but g is 9.8, sin 30 is half, so this is going to be 4.9 meters per second square, which is option A. Done, done. Very good. See if this is clear in everybody's head. So what we had to do, we cannot use any formula as such, but we had to solve this question using Newton's laws. The question said tangential acceleration, angle was given and nothing else is known, okay, because alpha is not known. So the best way to do that is resolve the forces, and we saw tension is not along the tangent, mg's component is along the tangent. That's what I was telling you. there is always some force which will be along the tangent or a component of it. That is something which will behave like tangential force. And in this case, tension and mg cos are the centripetal forces. Very good. Done. Let's move on to the next one, 4.9 meters per second square. Okay. Now, I think there was a printing mistake over here. This, I remember I had asked for this to be changed long time back, but I think it didn't get changed. This was supposed to be 7, guys. Anyways, so this was supposed to be 7 meters per second. Now, the next part of the question is, what is the tan of the angle between the net acceleration and the velocity? Very interesting question. What is the tan? Let's see what is the question. The tan theta is what they are asking. Now, what is theta? Theta is the angle between acceleration, the net acceleration, and the velocity. Okay. First of all, where is the velocity going to be? We all know that this particle will have some velocity, let's say like this. So this is where the velocity is, and it will have two kinds of acceleration, correct? One is the centripetal and one is the tangential. So centripetal will be always towards the center. Tangential, we just saw, it will be like this. We also just obtained the value of tangential acceleration in the previous question. This is just an extension of the question, right? So tangential will be here and centripetal always will be, my warriors, towards the center of the arc or towards the center of the circle. Yep, join in, no problem, Gokulnath. It's okay. Zayad, you also join in. You guys were late, but yes, let's continue and you can watch the replay of the missed part. Now, the question says the angle between net acceleration and the velocity. Centripetal is here, tangential is here. Obviously, the net acceleration will be somewhere here, which will be the vector sum of both of them. That means this angle over here is nothing but theta. Acha. Now, if this is theta, and we have been asked the tan of the angle, tan theta will be opposite by adjacent. That means what is asked? Tan theta is nothing but, what is it? AC by AT. This is what is asked in the question. Out of AC and AT, from the previous part, we already figured out AT was 4.9 meters per second square. That was already done. The only job left is to find AC. Let's figure that out. So how do I find AC? Think about it. Centripetal, I think I can use V square by R because V is known and radius, that's 10 centimeters. So how about that? V square by R. V is 7 square. R, that's 0.1. 7 square is 49 divided by 0.1, which is 490 meters per second square. So the only job left is to find tan theta. So tan theta will be AC. AC is 490 divided by 8t, which is 4.9. Now this is very obvious. This is 4900 divided by 49. So this is nothing but 100. So tan theta is 100. Excellent deduction. Very good. Understood? Clear, my warriors? So in this question, the language looks different. The tan of the angle between the acceleration and the velocity. Do it step by step. We broke down the problem. So I'm teaching you how to solve problems. Some of you face that difficulty. Acceleration will be a combination of center and tangential. Centripetal always towards the center, tangent along the tangent. Velocity is always along the tangent. So between A and V, this is the angle. So tan of theta will be this by this, opposite by adjacent. That's it. Done. Very good. Chalo. Let's get moving to the next question coming up on your screen. Yeah, the answer was 100. Yeah. A car of mass 1000 kg, is moving with a speed of 30 meters per second on a circular path of radius 300 meter. If its speed is increasing at the rate of 4 meters per second square, what is the net frictional force on the car? Very interesting question. Let's try to visualize this first. Okay, so let's say this is our car. Okay, so this is our car, and let's say this is our road. Okay, the car is going like this with some velocity. What's the speed? That's 30 meters per second. This is the top view. Okay, Circular path radius is 300 meter. So this is 300 meter. Okay, this is the center. Now, what is the direction of the net friction? Well, it is clearly mentioned that the car's speed is increasing. Now, whenever you see this word, speed is increasing, you should always recollect this will be nothing but the tangential acceleration. Because tangential acceleration is the rate of change of speed. I just told you this. That means this car has some tangential acceleration along the path, along the velocity. Its speed is increasing. Also, additionally, it should have towards the center the centripetal acceleration. Why? Because the direction is changing, is going in a curved path, circular path. Definitely it will have centripetal and tangential. What will be the result of both of them? Obviously the total acceleration. Great. So it will have something like the total acceleration over here. Very well. Now let's think about the forces. mg, the weight. Since you are looking at this from the top view, you are looking at it from the top, gravity will be inside the plane of the board. So mg will be inside. There will be a normal force towards you out of the plane because the ground surface is the plane of the board. So normal, the contact force will be towards you. Okay, so I'm showing it like a dot, like an arrow coming towards you. Now, apart from normal and weight, there is only one force remaining, and that is friction. Now, think about it, my warriors. Where would friction act? Will it act along AC? Will it act along AT? Or will it act along A? This is a very trick question. Let's see how many of you are going to get this right. Come on, my warriors. Where do you think the total friction will act? Will it act along AC? Will it act along AT? Or will it act along A? Remember, there is no other force apart from friction. There is no other force. Hi Naveen S, welcome aboard. There is no other force apart from friction. Well, it will act along the surface for sure, but it will act along, well, many of you are saying AC, and that is definitely wrong. Definitely wrong. That is wrong, guys. Because if it acts along AC, who is giving tangential acceleration? Answer that question then. Who is giving tangential acceleration? Which force is giving? Normal, mg? No, it's perpendicular. So there is no other force. That means the only possibility is friction is actually split into two components. A part of the friction gives centripetal, a part of the friction gives tangential. So the total friction acts in this direction. That's it, as simple as that. So Naveen, we started the class at 7:30. All my classes are always at 7:30 unless and until if there is some change. Dexter, this is a pure English channel, and you know, in English channel, then students ask, sir, pure English mein bolo, because then you know it is not possible. So we have two different channels. Okay, one is Hindi plus little bit of English, so for all the Hindi speaking students, and then we have this channel for all the students who want to learn in English, irrespective of whether you know Hindi or do not know Hindi. Okay, so this is an English medium channel, so it's not exclusively for some people or NRIs or no, nothing like that. Okay, chalo. So then what do we get? This frictional force will be mass into acceleration. Oh, but I don't know the acceleration. Can I figure that out? I think so, because the value of tangential acceleration was already mentioned. It is nothing but 4 meters per second square. Can I find out centripetal acceleration? I think so. Use the formula v square by r. Velocity is 30 square divided by radius. Radius is 300. So 300 and you have 30 square. 30 square is 900. 900 divided by 300, that's 3. So this is 3 meters per second square. Now if this is 3, this is 4. How much will this be? It's obvious, right? How much will this be? This will be the vector sum. So use Pythagoras. This will be 4 square plus 3 square, which is nothing but 5 meters per second square. Understood? Oh? Clear? Oh? Let's write this now. Mass, that's 1000. Okay, multiplied by acceleration, well, that's 5. So this will be 5 into 10 to the power 3 Newton, which is 5 kilonewton. Many people get either A or B, and they are all wrong. Yep. Yes, Dakshin, that's the correct answer. All right, understood. Oh, very good, Anil. Excellent. Oh, why is the class tomorrow at 2:30? Is it? Well, I'll change it. But it's by mistake. Don't worry, guys. It will be most likely at 5:30, not at 2:30. Okay, just ignore. I will thank you for pointing it out. Although, so either 5:30 or 7:30. That's when I'll keep the class. All right. Okay. Let's move to the next concept. But before that, let me tell you guys, all my warriors, in case you are having some difficulty and you feel that you cannot get the right answers in the right time and you're not so sure of the methods and also maybe of the answer that you get online, and plus it's risky to ask somebody whom you think himself or herself is doubtful. So it's always best to use our Vedantu app and ask our doubt experts. You can take a picture, you can chat, and you can send your solutions, you can ask for any corrections, you can also ask doubts and also ask for hints for getting to the final answer. And it's all free of cost. So if you are in the pro subscription, and there is no limitation on the number of doubts you ask. So use this feature by downloading the Vedantu app only. Now let's move on to the next part of the lecture, where we are going to discuss exclusive questions on vertical circular motion. And you would have seen some really amazing adventures where, there's a person and he goes, in a circular path, is using a bike or a car. It's called also the well of death. And you might have also wondered, if you hold a thread with a bob, how much velocity should you impart so that it completes the circular motion in the vertical plane? Have you ever wondered that? Well, if you have not, maybe you should start wondering now. And let's start solving questions on that. So, this kind of motion in vertical plane is also non-uniform circular motion. Why is it non-uniform circular motion? Yes, I can see your messages. Thank you, Om Satpute. So the thing is, my warriors, the gravity plays a role. When it is on the top, the speed will be less. As it comes down, the potential energy gets converted into kinetic energy. And the moment that happens, what will happen next? The speed will increase. And the moment the speed changes, we know what will come, the tangential acceleration. So now, look at these colors beautifully explaining you everything. This two light yellow or oranges arrow mark are nothing but the acceleration vectors. Look at that. These are acceleration vectors, and the red one is the total acceleration. The green one is the velocity. Notice how the orange line along the tangent is increasing the speed. The moment the speed increases, you can see the centripetal acceleration changes because it is v square by r, right? And hence the total acceleration also changes the direction as well as its magnitude. So the point over here is in the vertical circular motion, you will see apart from the centripetal, you also have tangential, and the tangential is responsible for the speed changes. So when you leave it, it increases the speed, decreases the speed, increases the speed, decreases the speed. That's what will happen. Now, to solve these problems, I am going to give you some important pointers. Probably it should be in your notes as soon as I show it to you, or you can also download the PDF from the Telegram channel link, which is again there in the description box below. So, first of all, whenever you see vertical circular motion problems, what you should do is always think about energy conservation. 90% of the times these problems generally involve some kind of energy conservation. Kinetic energy got converted into potential, or potential got converted into kinetic, something like that. Next thing that is most likely going to be used is Newton's laws, where you draw tension, or if it's a rod, maybe a normal, or if it's a loop where there's a car going, maybe again a normal force. So normal is there, gravity is there, or friction is there. So some kind of Newton's laws will be there. You might have to split the forces and then try to solve for tangential and centripetal. So Newton's laws is generally involved. Next thing, the speed keeps changing due to gravity and other forces by chance if it is present. See, usually these kind of problems have, gravity present, but maybe when you learn electrostatics and magnetism in 12th standard, you might have some electric field and magnetic force in the problem which is trying to change the velocity. So most likely it is going to be gravity, but in some exclusive cases which you might deal later on in the next standard will be, changing the speed. The moment the speed changes, remember it is a non-uniform circular motion. If the string becomes slack, you might hear this word very often. So the string becomes slack. So you throw a ball Okay, it's tied to a string, and maybe it loses the velocity so much that the string collapses. That is the meaning of the string becoming slack. So the moment the string becomes slack, the tension force which was trying to pull the ball, that force vanishes, so the tension becomes zero. Keep this in mind. Okay, the string becomes slack, so maybe the ball has lost velocity, the string collapses, that's tension is equal to zero. You might also hear this word, the body loses contact. So imagine a car going in a loop and it's going like this, and as it goes up, the speed reduces so much that it loses contact from the surface. It falls off from that surface. When that happens, the normal force will be zero. Keep this in mind. Alright? Now, apart from this, one last important point that you should keep in your notes, rod can never become slack. Strings can become slack. If you have a string, as the speed reduces, the string can collapse. But like a pen or a rod, even if the speed reduces, the rod won't crumble, it won't collapse, the tension won't vanish. So a rod can never collapse even if you hold a heavy mass on top of that rod. The rod will still be able to hold it. But a string, can you have a mass over the string and you're holding from below? Obviously not, it will collapse. A string can only extend, it can never ever compress. But a rod can extend or compress both ways. I hope this is clear. Hello Kanyaram, Hari, welcome aboard. Join in, you should be more regular. Yeah. So let's start solving some questions on this. In a vertical circle of radius r, at what point of the particle is the tension may be zero? What do you think? In a vertical circle of radius r, at what point do you think in its path the particle may have zero tension? Highest point, lowest point, at any point, at a point horizontal from the center of the radius. Where do you think, it may have zero tension? Well, very good, Molesh, Paulnimi, Dakshin, excellent Isayad, and the correct answer, Roshni, very good, is the highest point. And we know that, in a vertical circular motion, this is the point where the string might just become slack, and that means the tension will be zero. So this is the highest point. As it goes down, the speed increases, so the tension will be there at all these points. So hence option A, perfecto. Now let's solve this question. There is a block of mass m at the end of a string, okay, and it is whirled in a vertical circle of radius r. What is the critical speed of the block at the bottom so that it completes the vertical circular motion? Well, let's try to do this. So at the bottom, it needs some critical speed u, which I do not know. That's exactly the question. So that it completes the vertical circular path. Now, as it goes up and reaches here, do you think the speed will remain constant as this ball goes up? What do you think? Will the speed remain constant on the top? Obviously, the kinetic energy will lose out to the potential energy. So the speed on the top will definitely be less. Now, in order to find this speed, I think I need this speed, because remember I gave you some pointers. Vertical circular motion generally involves energy conservation. Yeah. So let's do that. Critical speed, Harita, means that speed for which it is just able to complete the circle. If you give more speed, it will definitely complete the circle. But if you get less speed, or if you give it less velocity, then maybe it will become slack and it will fall down. So it's that Lakshman Rekha. Above this, good. Below this, not good. At that speed, yeah, just it is able to complete the circle. That's what it means. That's the critical value. Okay, Lakshman Rekha times. Now, using energy conservation, let's see what do we get. Energy conservation. Here is what we'll get. I will get initial kinetic energy plus initial potential energy will be final kinetic energy plus final potential energy. Initial kinetic energy, because the speed is u, I'll just mention half mu square. Initially, let's just assume this as zero level. Okay, there is no harm in doing that, right? So this is my zero reference. Okay, so if it's my zero reference, obviously initial energy is zero. final kinetic energy over here, that's speed v, so half m v square plus final potential energy. As compared to zero level, how high is this ball as compared to this point? Well, this is radius r, this is also r, so this is the diameter, so it should be 2r. Yeah, the radius of the circle is r, so it is nothing but mg into 2r. Interesting. Now I want to find u. You can see that in this question. I do not know v. If I somehow find v, I will definitely be able to find u. Anyways, I'll just multiply by 2 and cancel m everywhere. So u square will be equal to v square plus 2 into 2, 4gr. Okay, this is what I got. Now, you have to use some common sense and some physics conceptual understanding. If it is just able to complete the circular path, remember the previous question said, if at all, it loses or the string becomes slack, the tension becomes zero, it will be at the highest point. So at that critical moment, the tension just becomes zero for a moment, and the moment it goes above the highest point, again the string becomes taut. So understand, as it goes up, speed reduces. At the topmost point, the tension becomes zero, but it has momentum, so it goes ahead. As soon as it goes ahead, it gains speed, and again the string becomes taut. So at that critical moment, what if the tension gives hath? It says like, okay, I give up. So this is tension is equal to 0 at that instant, momentarily, at that instant. Okay, but at the next instant, we know as soon as it comes down, again the tension will build up, it will come out over there. I hope this is clear. Yes, Susan, it will be. Hi Ria, welcome aboard. Raghu Raman, I'll be doing some KVPY classes, and then we'll also come to the next chapter by this week for sure. That's going to be center of mass. Now there is one more force apart from that, and that is obviously mg. And yes, it will be changing the direction, so it also has centripetal acceleration. So this completes my free body diagram. And remember, some time back I told you energy conservation, Newton's laws, etc. has to be used. So let's use Newton's law and see what do we get. So I will get mg is equal to mass into centripetal acceleration. Remember, the tension value is nothing but 0. Otherwise it would have been tension plus mg is equal to mac. Newton's laws, force is mass into acceleration. Mm goes, so g will be equal to ac. Okay, mm goes. What is centripetal acceleration? Well, that's v square by r. Oh, I figured out what v square is. V square is rg. So let's use v square as rg over here, and I think I'll be able to solve the problem. So plus 4gr is equal to u square. So therefore, what I will get? U square is equal to 5gr. So therefore, u will be root of 5gr. So this is my critical value. So for all speeds more than equal to root 5gr, it will complete that vertical circular motion. If the speeds are less, it will become slack, it will fall down. Makes sense? Understood? Yep, Lalitalan Zoa, definitely bacha. Okay, what a brilliant way of solving this question. So energy conservation, like I told you before, it has to be used, and Newton's laws will also be generally there in vertical circular problems. And the concept here was just when it reaches the top, that's the instant when tension becomes 0 for a moment, and next instant it again catches up. That's what has happened. Okay, so root 5gr. Now I'll just change the word to a rod, and you will see how things will change. Oh, Raghotaram, don't worry, bacha, I will get it corrected, Raghotaram. Don't worry. Okay, I'll get it corrected. So here is the thing. First of all, if it is a rod, what things will change? Let's try to figure this out. Again, the diagram remains the same. This is U, this is V, and this is, let's say, my 0 reference and all of that. Okay, this is my 0 reference. Again, using energy conservation, same thing. Initial kinetic plus initial potential is equal to, final kinetic plus final potential. I'm just going to get the same thing as before. So I'm just going to get u square is v square plus 2gr. This is exactly like before, nothing different. No steps have changed till this point. It's the same thing as of a string. Now comes the critical part. Will a rod have root gr velocity at the topmost point as a critical velocity? Because for a string, we thought that the tension will become 0. That's when it becomes slack. That's why it needs to have some minimum speed. So for a string, it needs to have some speed on the top so that the string does not become slack. But for a rod, even if the speed is very less, as long as it is something more than 0, even if it is 1/100th of a millimeter per second, the rod will never collapse. Rod can always bear that force. So this velocity, if it is more than 0, doesn't matter. There is no slack over here. Very, very important. It's a rod. Keep this in mind. It's a rod. It can definitely bear that. Any speed more than 0. But the question says the critical speed. So when it is critical, it is just nearing 0. It just reached there. If it somehow just reaches there, I know if I give it some push, it's going to go on the other side. Yep. I hope this makes sense. Yeah, I'll repeat this. So the moment it is a rod, okay, even if it just becomes 0, it has almost reached the top. So any speed which is like 0.00001, which is almost like 0, that also does. So this velocity is going to be 0, and therefore I'll say u square is equal to, I think, oops, guys, I think this was 2 into 2, my bad. This was 4gr, okay, because from the previous one, okay, this was supposed to be 2 into 2. I just made a small blunder while remembering that equation, but anyways, it's 4gr. So u square will be 4gr. Therefore, u will be equal to root of 4gr. This is the answer. So that means for all speeds which are more than or equal to root 4gr, it will be able to complete that complete circular motion. So this is for a rod. For a string, so for a string, what was it? So for the string, the speeds were, what were the speeds? More than or equal to root 5gr. So who has more speed requirement? It is the string. Why does string require more speed at the bottom? Reason is, when it reaches the top, it cannot have 0 speed. It needs to have some speed so that it will be able to have some bit of pull or some bit of tension. Yeah, I hope this is clear. Excellent. So that's the difference between a rod and a string, and I hope it has entered your head. Yeah, root 4gr. Now let's solve this question. It's a brilliant question coming up on your screen, and I'm pretty sure you would have seen this kind of a stunt or some kind of, circus, and this might have always wondered you how this happens, and let's see how we can do this question. Okay, so Raghu, I have already put up the solution for the last homework problem, and definitely if you still have some doubt, please leave a comment, bacha. I'll definitely help you out wherever you got stuck. The solution was there in the previous PDF, but still don't worry, I will help you out when you leave a comment after the video ends. Okay, chalo. The minimum height from which the roller coaster should start. You would have seen these funny roller coaster videos. They just reach the top and then suddenly speeding reaches and it goes upside down, and it is able to complete the complete circular loop without losing contact. The question is, what should be the minimum height from which the roller coaster starts? What a brilliant question, guys. Let's start solving this. So let's take this as our ground level. Oops, 1 second. Okay, let's take this as our ground level. Okay, this is our ground level. Let's say I call it my 0 reference. All right, and it just starts. The minimum height from which the roller coaster should start. The moment this word start is used, the velocity is roughly 0. It's just given a small push, gentle push. Starts accelerating, zoop karke. Very good. Let's see how to solve this now. Now, thank you Susan, thank you Bachalo. The KVPY session is supposed to be tomorrow, Omkar. I'll get it changed, don't worry. So it accelerates, it reaches the bottom, and now here it should have some speed so that it does not lose contact. Okay, it should be able to complete the circular motion. Okay, it should have some speed over here. Remember, this situation is very similar to the situation of a thread attached to a bob, a point mass and a thread. At this point, the normal should be more than or equal to 0. It cannot lose contact. So normal force should be there. Remember this situation, whenever you see this kind of a loop and a mass, probably going around this situation is very much similar to a thread of radius r, and this is that mass m, and it's going like that. So this is nothing but, very, very similar. Reason is, instead of tension, you have normal. Instead of tension becoming just 0 at the topmost point, this normal should be just 0 at the topmost point. So FBD wise, equation wise, there is no change. There is no change. So if there is no change in these two situations, we know what is the speed requirement at the bottommost point. What was it, my warriors? At the bottommost point, what is the speed required for completing the circular motion for a thread? Was it root 4 gr, root 2 gr, root 5 gr? Yes, it was root 5 gr for a thread. For a rod, it is root 4 gr. So hence, we should assume that this speed is nothing but going to be root of 5 gr. Makes sense, my warriors, what I just did? This is nothing but like a thread which does not become slack, which does not collapse. So this roller coaster does not lose contact. So if it has root 5 gr speed, it will be able to pass this topmost point without losing contact. How do you get this speed? Well, from potential energy. So the potential energy, again, energy conservation. So energy conservation, I can again say initial potential plus initial kinetic will be final potential plus final kinetic. Initial potential, well, let's just assume this height to be h. So mgh plus initial kinetic, well, that's 0. Final potential, it's on the 0 reference, so 0. Final kinetic, it has some speed, so half m into root 5 gr square. Now mm goes, so gh will be equal to square of that, that's 5 gr divided by 2. Gg goes, so h is 5r by 2, which is nothing but 2.5 r. Very interesting. This is our final answer. By the way, guess what? This is r, this is r. So this much is nothing but 2r, correct? So extra 0.5 r is needed. So if you give this extra 0.5 r, assuming there is no friction, wind resistance and all of that, so then this roller coaster will be able to complete this. In reality, this height is slightly more because of friction and air resistance. You need to give that extra energy. So something here will probably make it go around this loop. So now you know how to design a roller coaster. Susan, I have already mentioned about the books and all of that, but you can leave a comment, bacha. I'll definitely reply to your comments on which is the book that you should follow and how you should study, etc. Just leave a comment after the video and trust me, I'll let you know. All right, my warriors. Yes, 2.5 r, that's the answer. Here is the next question coming up on your screen. So can you please make an estimation by when the crash course? Oh Durga, it has already probably been scheduled. It's probably from this Monday, if I'm not wrong. Yes, it was this Monday when the JEE 2022 crash course starts. So you can join it even right now. There is probably a link in the description box. Go ahead and join the crash course. It's there today. Okay. So Dakshin, don't worry. Even if you have your school, the pro subscription courses are always in the evening. We do not clash with the timings of the school. We are very well aware of that. And the timings of the classes are not like very large. And second thing, in online, what happens is the efficiency is much better than offline. So the class, efficiency being higher, you will not be wasting too much of time. Plus you don't have to even travel, around. So that works out. It's all the classes are in the evening. So let's try to solve this question. There is a bob of mass 200 grams at the end of a string of length 10 centimeters, revolving in a vertical circle with constant speed 2 meters per second. When the tension is 9 Newton, then the angle made by the string with the vertical is, come on, let's try to do this. Okay, so see guys, first of all, let's assume this is our string, this is our mass, okay, 200 grams, and this is some angle theta. Let's see what are the different forces acting on it. One is nothing but the tension, correct? And the second one is obviously the weight, which is mg. Now it's given that the speed is constant. Somehow you're trying to maintain that speed. So let's say this speed is over here and that speed is 2 meters per second. That surely means one thing: you might be applying some force in order to maintain that speed. I don't know what that force is, but I'm assuming it has some F. I don't care. Alright. Now I feel that I can resolve mg into two components. Let's try to do that. Okay, so mg, which was like this, I will split it, one over here and one over here. Alright, so this is something like that. Great. Okay, so this is like this, and here we have m, it just got run. Okay, so what are the two components of mg? Since this is theta and this is mg, so obviously this is mg cos theta and obviously this is mg sin theta. Now by the look of the diagram, obviously there must be some kind of centripetal acceleration, and by Newton's law, all right, the net centripetal force is mass into centripetal acceleration. This force will be the forces along this line. Tension is in the direction of acceleration, so tension. Mg cos theta is opposite to the tension. Notice it very clearly. Tension is in the direction, so plus. Mg cos is opposite, so minus mg cos theta is equal to mass into acceleration. Acceleration is v square by r. Very well. Now is the tension given? Yes, the tension is 9. Is the mass given? Yep, it's 200 grams, so 0.2. G, that's 10. Cos theta, I don't know, that's what I need to figure out. Mass again 0.2. Velocity is 2, so 2 square divided by radius. Radius is 10 centimeters, so that's 0.1. Okay, so 9 is as it is. 0.2 into 10, that's 2. Cos theta is equal to 0.1, 0.2 goes, so 2 into 2 square, that's 2 cube, that's nothing but 8. So take this guy over there and bring this 8 over here. So 9 minus 8 is 2 cos theta. So 1 is equal to 2 cos theta. So half is equal to cos theta. So naturally theta is equal to 60 degrees. Done, done. That's the answer. Perfecto. Excellent, Monish. Very good. Excellent, my warriors. Now, that was the answer, I believe. Yep, it is. Now, there are few questions which you need to solve at home. These are questions which I feel will boost your confidence, and it will also give you a flow and also a recap of whatever concepts you have learned. And whenever you try things on your own, that's when you actually learn. So this is your first homework question and this is your second homework question. Now, all our students put up the homework answers in the comment section. So this was our last video, lecture number 2, and you can see Ishpreet, very good, Anil, very good, excellent, Harita, excellent, and thank you Anil for all the love and hearts. It means a lot, bacha. Very good, Dakshin, excellent, Saja, Suchi. Okay, you failed to solve the calculation part, so took help of the calculator for the second question and still you got the answer. But Suchi, I would suggest even if you took the help, after that I hope you tried solving it on your own. That would really boost your calculation skills, mathematical skills. So try it out on your own also. Thank you, Davi, Mohammad Sal, Pratham, love you too, bacha. Thank you, Harshil. Okay, that's hard for all of you. Is this lesson same as the system of particles lesson? No, this is circular motion. System of particles will be rotational motion. So I'll anyways reply to that. And yep, a heart for you too. Is calculus uploaded? Yes, I have already replied to that as well. Now, you will also see one more interesting thing. Okay, in these description box, you will not only get the session PDF. Okay, so the entire PDF, whatever is there, you will see it over here. Not just that, you will also get a link for changing your display picture. So if you have not changed your display picture to this cool looking warrior picture, please do that right now so that you can show and extend your support. And also you will see the crash courses for CBSE and for JEE. Now you can see the JEE 2-year course is also there. This includes the 11th standard crash course plus the 12th standard full-fledged course. This will be till next year. Okay, so next year, sorry, JEE 2023. So the entire 11th standard and the 12th standard syllabus with revision classes and any other course like KVPY, etc., everything becomes free, including my classes. So what and all do you get in this? You get your live classes, recordings of that, you get your test series, and obviously the analysis, the report cards, etc. Not just that, you will get assignments, and you also get how many were correct, and you can solve it again and again. You can also see your progress. Not just that, even your live classes, you can see all the metrics like how your performance was, how attentive you were, and other different parameters which you will never get in an offline coaching. Doubt solving, so there is a 2-teacher model which we follow. So the second teacher is always associated with few group of students who is solving all your doubts. And after the class, you have this mobile app facility which I just showed you in the classic version, and you also get personal mentorship in the plus version. So if you're wondering what the price for 2 years is, that's hardly 53,999 rupees. It is very affordable, and you can also avail the EMI option out here. You can also try it out for 1 month, and if you don't like, it's okay. You can leave, no problem. But if you are convinced that yes, I want to learn from teachers like Shreyas sir, you can go ahead and click buy the complete course, and you can see you can use debit card, credit card, Paytm, Amazon Pay, Phone Pay, God knows so many options, including 0 interest. So if you choose 0 interest, you can see the price comes out hardly 4,500 rupees per month. That's cool. All right, so try this out. I will be really waiting eagerly to see all of you in the pro subscription courses. And also remember, there is an option to learn in English as well as Hindi. So most of our batches are in English, but if you want to learn in English, that option is also there. Thank you, my warriors. Excelente. Take care. And very nice to know that Suchi, you're improving with practice, and I wish you all the best, and don't worry, we are always there with you. Bye bye Anil, bye bye Roshni, bye bye Monish, bye bye Ishpreet, bye bye Saja. Take care, Durga. All right, Durga, can you do one thing? Can you just comment on the video? I'll definitely, the recent one, the video which is going on, I'll definitely reply to that comment. Okay. No, is this session in Tamil? No, it's not, unfortunately, but you are learning in English, so that's good enough, I guess. Take care, bye bye. This was Shreyas here, your Capto. Hasta la vista.